but I didn't know. Right. So, um, now that we're going over what we did in the last class, I want us to decide when we're going to have our next session, which is going to be free, by the way.
Oh, you sure?
Yeah, sure. I don't have a problem with that.
Okay. Right, let me just get my calendar up on my
All right,
phone.
go ahead.
Right, so um Monday I got my tutor.
Okay. What subject?
Um Biology.
Okay.
When Wednesday I got physics.
Okay.
Um Maybe we can do Tuesday,
Tuesday. By what time?
6:30.
6:30. Beautiful. Beautiful.
But
6:30.
text me back because I need to ask my parents to see if they're busy.
Okay, no problem. But I'll keep
Yeah,
Tuesday
yeah.
6:30 in mind, okay?
Okay, thank you.
All right, my pleasure. For your birthday that happened previous yesterday, how old are you now?
15.
Oh, that's beautiful. That's beautiful. You're doing amazingly well for a 15-year-old, and I want you to know that I'm super proud of you, okay?
Thank you.
All right, so let's get into the lesson for today. We're going to be talking about chemical formula, equations, and calculations. You can see what's on the screen right now, right?
Yeah.
Beautiful. So now, I hope you're with your notes and your pen, right?
Yeah, yeah, yeah.
Good. So by the end of today's lesson, I want you to be able to do a number of things. These are our objectives for the end of today's lesson. Number one, I want you to be able to define chemical formula and tell me what its importance is in chemistry. And then secondly, I want you to be able to write simple chemical formula for elements and compounds using valencies. This was the part where we had some issues in the previous class, and we're going to be taking it again, hopefully making it simpler this time. All right?
Yeah.
And then if we're able to achieve these two, I'm going to be excited, and then we'll do the remaining three in the next class, which is going to be free. Are we cool?
Yeah.
All right. So when are your examinations coming up?
No, not yet.
Not yet. All right then. So let's define what a chemical formula is. Are you with your notes?
Yeah.
Good. I want you to be writing. But before you write, can you see what's on the screen right now?
Yeah.
Good. Can you read it out for me?
A chemical formula is a symbolic representation of a compound showing the types of atoms present and their relative numbers.
Good. So first of all, a chemical formula is a symbolic representation. Do you know what a symbol means when they say symbol?
Like the short name for it.
Thank you, like a short form. For instance, name one element on the periodic table that
H for hydrogen.
good. Thank you very much. For instance, we have hydrogen. Instead of writing hydrogen fully, A to Z, in chemistry, we just simply use the symbol H. So whenever a scientist sees this letter H, he already knows that you're referring to this element called hydrogen. In other words, the symbol or the letter H is a symbol for hydrogen. Do you understand that?
Yeah.
Beautiful. So a chemical formula is a symbolic representation of a compound showing the types of atoms that are present and their relative numbers. Do you know what a compound is?
Um, no, I kind of forgot that.
All right, beautiful. I'm going to be refreshing your memory, okay? A compound is simply something that is formed when two or more elements are joined together.
Okay.
Can you write that down? A compound is something
All
that
right,
is
this
formed
down.
when two or more elements are chemically joined together. Let me write it out on the screen so you can write that out, okay?
Okay, yeah, go on.
All right, beautiful. So write as I do. A compound is what is formed. when two or more elements are chemically joined together. Have you written that down?
Just writing it now.
All right, beautiful. When you're done writing it, let me know so we can proceed.
Okay,
Are you done?
sorted. Yeah.
All right, beautiful. So, for example, we have the first example, which is over here, H2O. H2O is a compound, and the name of that compound is called water. Did you notice?
Okay.
Good. So, if you look at this over here, we have a number of elements. How many elements do we have over here?
Um, Two.
Good. Which one and which one?
Hydrogen and oxygen.
Thank you. We have hydrogen and we have oxygen. Romari, I want you to know that you're absolutely a brilliant kid. You're making me so happy right now answering all the questions that I'm throwing your way.
Thank you.
And I want you to know that if you continue like this, there's nothing that's going to stop you, okay?
Thank you.
Good. So you can see hydrogen and oxygen are combined together in this chemical formula, H2O. Remember our definition for a chemical formula. It is a symbolic representation of a compound. Now, in this case, the compound is water. So instead of writing water with the letters, all we simply did was to show the elements that are present, H2O. Now remember, the formula shows the types of atoms that are present and their relative numbers. So in this case now, this is the formula for water. It is showing us the atoms that are present, hydrogen and oxygen, and it is also showing us their relative numbers. You can see these two over here, right?
Yeah.
Good. That two is simply telling you that we have two atoms of hydrogen. Did you see that?
Okay.
Good. And then oxygen over here, you can see there is no number in front of oxygen. Oxygen is just standing alone, right?
Yeah.
Whenever you see that in chemistry, what we simply mean is that that element has just one atom present. So we have two atoms of hydrogen and just one atom of oxygen.
Okay.
Any questions?
No, no.
So can you define a chemical formula for me?
A chemical formula.
Good. Can you define it for me?
A chemical formula is like almost like the method how you work something out.
Okay. Okay. How about this definition that I gave you on the screen? Did you write that down?
Oh, let me check if I wrote it on last lesson.
No, 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 no. I don't want you to refer to your last lesson. You know, we are redoing it one more time.
Fresh.
So, yes, so I want you to write
Okay.
important stuff down. Write down this definition on
Okay.
the screen. A chemical formula is a symbolic representation. Okay?
Yeah.
Good. So, uh, these two places that I underlined, this and this, I want you to write them down. And when you're done, let me know so that we can proceed. Are you done?
Yes.
Good. So now, Romario, can you give me an example of a compound that you know?
Um, a compound. I only understand like the definition of a compound, but like what can you give me an example of one so I can write
Okay,
it down?
here is an example, water.
Okay,
You
so
can see,
hydrogen would be a compound.
no, hydrogen is not a compound. Hydrogen is an element. But water is a compound because I told you that a compound is what is formed when two or more elements are chemically joined together. Did you write that definition down?
Oh, okay. So it's like, um, oh, okay. I understand what you mean. Yeah.
Yeah, when you have two or more
It's like when you
elements.
mix flour, eggs, and milk, it makes
Good,
pancakes.
good. So now when you mix elements together, they make compounds.
Yeah, yeah.
Do you understand it now?
Yeah, let me just
S-
write this example down.
All right, good. So while you're writing, can you give me another example of a compound that you know?
Let me think. Like the science way or just something normal?
Science way.
Um, oh. Can I look at my periodic table?
Sure you can, but you won't find any compounds there though. But you can.
How about helium noble gas?
Helium is not a compound. Helium is an element. Can you see what I'm writing on the screen right now?
Yeah, carbon dioxide.
What is the formula for carbon dioxide?
Um, I'm not really sure.
Okay, it's called CO2.
Oh, so the nickname.
Ever come across this before?
Yeah, of course.
All right, so this is another example of a compound. What I just ticked right now.
Yeah.
What is this called?
Um, Carbon dioxide, CO2.
No, this one that I
Oh,
just underlined.
oh, one sodium atom and chlorine.
It's called sodium chloride. Okay, so those are examples of compounds that we have. So now I want you to do two things. I want you to define for me what a chemical formula is, and I want you to define for me what a compound is. Can you do that?
Okay.
Good.
So what a chemical formula is and a compound formula
What a compound is. Define a chemical formula for me first.
is a symbolic representation of a compound showing the types of atoms present and their relative numbers.
Good. How about um a compound? What is a compound?
A compound is what is formed when two or more elements are chemically joined together.
Beautiful. Beautiful. So now we want to learn how to write chemical formulas using the valencies. Are you there?
Yeah.
Good. So first things first, let's define what valency is before getting into the concepts of learning how to write formulas. So the basics, valency simply refers to the combining capacity of an element. Now, don't get confused by this statement over here, okay? A simple way of saying that statement is how many electrons an atom gains or loses or shares. So if anyone comes across you and asks you, Romario, can you help me with the definition of the term valency? Just simply say valency simply means the number of electrons that an atom gains, loses, or shares. It's as simple as that. Did you get that?
Okay, let me write this down.
Okay. So while you're writing it down, let me help you. Valency means the number of electrons. I hope you're writing it down as I am.
Yeah, I am.
The number of electrons an atom gains, loses, or shares. Go ahead and write that down.
Sorted. Yeah, sorted.
Are you done?
Yeah.
Good. Are you there?
Yeah, yeah.
Beautiful. So now, here are the steps for writing a chemical formula. Step number one. What is it? I just ticked it now. Can you read it for me?
Write the symbols of the element.
Good. Step number two.
Write their valencies.
Good. Step number three.
Swap and balance valencies. Cross
Good.
method.
Good. So, for instance, if I have, let's say, two elements, let's say, hydrogen, and I have oxygen. This is the symbol for hydrogen, H, and this is the symbol for oxygen, O. So if I am to write the chemical formula for these two, the first step says write their symbols. I'm going to write it H and O. Did you see how I did this?
Yeah.
Good. The next thing to do is to write their valencies. I'm going to be showing you how to calculate valency, okay?
Okay.
Good. For this example, the valency of hydrogen is 1 and the valency of oxygen is 2. Don't worry, I'm going to show you how to calculate valency. So that's step number 2. And then step number 3 says swap and balance the valencies. So here is what it means to swap. I'm just simply going to draw an X to cross these two elements with the valencies. Did you see what I just did, Romario?
Yeah.
Good. So that means H is going to take the number 2 and O is going to take the number what?
Oh.
O, what number is O going to take?
Zero.
What number is O going to take? Where is the arrow pointing to?
Two.
Look at O over here.
One.
So O is going to take the number 1. Now remember I told you in chemistry, we don't usually indicate the number 1 when it's standing after an element, okay? So in a chemical formula, if it's the number 1, you can simply eliminate it. So we have H2O. Did you see this?
Yeah.
Good. Now let's take some
The
examples.
thing I was struggling with,
Yes.
when you sent me the thing on Google Classroom,
Can you,
yeah,
yes. Can you,
um, it was this to write the formulae using valency rules,
mm-hmm.
NgCl2.
Mg, MgCl2. This
Yeah,
this one's right. This one, right?
yeah.
Okay, don't worry. We're going to look at those examples, all right, in today's class. So I don't want you to be scared, all right?
Right.
All right, so here are the steps to calculate valencies. Romari, can you read the first step for me?
Count the number of electrons in the outermost shell.
Good. Next.
Count the number of electrons that must be gained for it to reach 8.
Good.
Count the number of electrons that must be lost for it to reach 8.
Good.
Pick the lesser number that is your valency.
Good. So for example, now, Romario, let's say we have chlorine, right?
Yeah.
Good. Let's say the number of electrons in the outermost shell of chlorine are 7. This rule simply says count the number of electrons that must be gained for it to reach 8. So if chlorine has 7 electrons in the outermost shell, how many electrons must be gained for it to reach 8?
1.
Good, very good. So that means 1 is the valency. Did you see that?
Can you write this in sentences so then I can write this down?
All right, so hold on for me. Romario, hold on, I'm typing it out for you, okay?
Alright, no worries.
All right, now. I've written it down for you. All right, you can write down what's on the screen right now. Are you there,
Okay.
Romario?
Yeah, I'm listening.
So
Yeah.
go ahead, write down what's on the screen. Everything
Thank you.
from the definition of valency to the steps for writing a formula and then how to calculate valency. When you're done, let me know and then we'll proceed from there.
Okay.
Good. Are you done?
Almost.
All right.
How many students have you got at the moment? Like, how many free lessons are you doing? Like, how many students?
Okay. How many students have I got on Preply?
Yeah, and like, how many do you have like privately?
Just you. I don't have any other one.
And then privately?
Yes, just you.
Oh, and then the public one?
That's the group you left. That's the only
Yeah.
one that I have for now, and they are free lessons actually. So they're about 90 students.
90.
Yes.
Wow. Are you gonna start charging soon?
Yeah, the free classes are meant to serve more like a bait to hook them in. So at the end of the month, I'm going to offer my paid classes to them. So for now, you're the only private students that I have.
Uh, you should do live streams.
Oh, really?
Yeah. You'll get lots of followers.
Okay. Well, I never
Yeah.
thought about this. Maybe we'll talk about it at the end of the class, okay?
Yeah. Remind me, yeah.
All right, sure, I will.
All right, I've written it down.
All right, beautiful. So now that you've written it down, let's take some examples. So now, Romario, here's the deal. You have the steps for writing a formula, right?
Yeah.
And you have the steps for calculating valency.
Yeah.
Good. So as we're looking at the examples, you're going to be telling me the steps as I ask you, and we're going to be doing them together, okay?
Sure.
Good. So now we're looking at this first example. The first example says, write the formula using valency rule. So we have the first one, water, H2O. Okay?
Okay.
Good. So first things first, what is the first rule or the first
All you
step?
got to do for the first step is write the symbols of the elements, which is
Good.
H and 0.
It's not zero, it's O. O for oxygen.
Oh yeah, H and O.
Good. So you can see we've written that down, all right?
Yeah.
Beautiful. Now you can see over here the atomic structures for H, hydrogen, and O, oxygen, right?
Yeah.
Beautiful. So the next step says what?
Um, it says write their valencies,
Good. Now, what is valency?
combining the capacity of an element.
The combining
Capacity.
capacity of an element. But if you are a bit confused with that definition, you can simply say the number of electrons that an atom gains or loses,
Yeah.
right?
So
Good.
wait, number
Of electrons.
of electrons.
Good. That an atom gains or loses. Are you there?
Yeah.
Good. So now I showed you the steps on how to calculate valency, right?
Yeah.
Good. Now this is hydrogen. How many electrons does it have?
One.
Good. How many can it lose?
One.
Good. So the number of electrons it can lose is one. And remember, the number of electrons that an atom gains or loses is its valency, right?
Yeah.
So
So
if
it's
hy
one. One for
good,
hydrogen.
good, good, beautiful. One for hydrogen. I've written the valency for hydrogen, right?
Yeah.
Good. Now, the steps that
Six
I
for oxygen.
now hold on. I like how you're excited and you're moving, but before we say six for oxygen, the steps for calculating valencies, what were the steps that I gave you?
Um, to calculate it,
Yes.
count the number of electrons in the outermost shell.
Good. So now let's count the number of electrons in the outermost shell for oxygen. I have one, right?
Yeah.
Count with
Two,
me. Two,
three,
three,
four,
four,
five, six.
five, six. Thank you very much, Romario. Superb work. So we have six electrons in the outermost shell. What is the next thing to do to get the valency?
So count the number of electrons that must. Oh, so it needs two to reach eight.
Thank you. So how many more electrons does it need to reach
Two,
eight? So what is the valency?
two.
Thank you very much, Romario. Beautiful. This is what I need from you. Beautiful. So we've written the valencies down. So what is the
So now all
next?
you got to do for the last step is swap.
Thank you.
Cross method.
Thank you. Can you hear me clapping for you?
Pardon?
Can you hear me clapping for you?
Yeah, 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 yeah.
Thank you. So let's swap now. So swapping, I have H. Good.
H2O1.
Thank you. So I have H2 and then O1. Now, remember,
And then you have to supply it.
thank you. So I'll just write my H2O. I don't need to indicate this one. Did you see this?
Yeah.
Was it difficult?
No, it's easy.
Thank you very much, Romario. Let's do the next example, shall we?
Yeah.
Good. So the next example we have is sodium chloride, NaCl. So let's go ahead and do this example. How do we do it now? First step is what?
Write the formula using valency rules.
Yes, so what's the first step now?
Oh yeah. Write the letters, write the symbols. NaCl.
Good. Na stands for what element?
Um, Let me just check. Oh, sodium.
How about Cl?
Chlorine.
Good. So I've written them down. What is the next step?
Count the outermost shell. So there's only one, but
Hold
you
on,
need seven to reach eight.
hold on, hold on, hold on, Romario. The next step says calculate the valencies.
Yeah.
Good. So how do we calculate the valency? Now for
Count the
sodium.
number of electrons in the outermost shell, so
Good,
the outside part, which is one.
good. So let's count now. We have just one electron in the outermost
Yeah,
shell. Did you see that?
yeah.
Good. So now, how many electrons does it need to gain in order to reach 8?
Seven.
It needs to gain 7 electrons in order to reach 8. Now, watch. How many does it need to lose in order to reach 8?
What was that?
How many electrons does it need to lose in order to reach 8?
One.
Good.
Oh.
Now, watch this, Romario. I don't want you to get confused. Watch.
Yeah, I'm getting a bit confused here.
Yes, yeah. Let me take that again. When you want to calculate valency, okay? Are you
Yeah,
there? Are you with me? When you
yeah.
want to calculate valency, you are going to count the number of electrons that an atom needs to gain and the number of electrons that an atom needs to lose in order to reach 8. So for example now, let's say sodium over here, for example, okay? Hello,
Yeah,
Romario, are you there?
yeah.
I don't want to lose you on this one. Don't get confused, okay?
Yeah, I'm listening.
All right, good. If an element needs to gain 6 electrons for it to reach 8, and it needs to lose 2 electrons for it to reach 8, the valency is going to be 2 because you always pick the lesser number. I'll
So
take
it's
that.
always going to be the smaller number.
Thank you. You're going with the smaller number. So now look at this example now.
Yeah, go
We're
on.
talking
Yeah.
about we're talking about sodium, right?
Yeah.
It needs to gain 7 electrons for it to reach 8, right?
Yeah.
Good. But
8 minus 7.
if it loses this 1 electron over here, it's
Yeah.
going to have 8 electrons in its outermost shell. Look at this. 1, 2, 3, right?
4, 5, 6, 7, 8.
So if this 1 electron over here goes away, that means 8 electrons will be in the outermost shell. Is that correct?
Yeah.
So now it needs to gain 7 electrons for it to reach 8, and it needs to lose just 1 electron for it to reach 8. Which one is the smaller number?
1.
So what is the valency?
1.
Thank you.
I
Should
still
I?
don't get it.
I'm going to explain it one more time. Okay? Now,
Okay.
hold on. I'm going to type it out.
Yeah.
So hold on for me to type it out, okay?
Yeah.
All right, Romario, I've typed it out for you. I want you to write down what you can see on the screen right now. Can you see
Okay.
it?
No, not yet. Yeah, now.
All right. That place where I put notes, can you see it?
Yeah.
Yes, I want you to write it down. That's
Okay.
this whole place.
Okay. Give me 5 minutes. I'm gonna rewrite it nicely.
All right, go ahead.
Yeah, no?
Yeah, I'm with you. Can you hear me?
Yeah.
All right, beautiful. Note, when calculating valency, count the number of electrons that need to be gained in order for it to reach 8. Did you see that?
Yeah.
Good. Also count the number of electrons that need to be lost in order for it to reach 8. Whichever number is less, that becomes the valency. We always go with the lesser number. Now, let me explain, Romario. Are you with me?
Yeah.
Good. Look at this atomic structure over here for sodium. Do you see it?
Yeah.
Good. Now we want to calculate the valency. How do we do that? How many electrons does it need to gain for the outermost shell to reach 8?
7.
Good. That is beautiful. It needs to gain 7 for it to reach 8, right?
Yeah. Okay.
Good. Now, I want you to look at it. Over here, we have just 1 electron, right?
Yeah.
But on the second shell, we have 8 electrons. Is that correct?
Yeah.
That means if this 1 electron goes away, it means we'll now have 8 electrons in the outermost shell. Is that also correct?
Yeah.
So how many electrons does it need to lose in order to reach 8?
One.
Good. In order to reach 18, it needs to lose one electron. So
Why
between,
is that?
yes, because look at this. Over here, there is just one electron over here, right?
Oh, and then there's eight there.
Good. So when that
But
one,
how come there's two on the first shell?
how comes there's two where? Two,
Uh,
two where?
like let me
Which
draw
one?
it here.
Which one is that? Okay, is it? Okay. Yeah, the first shell always has two electrons because the first shell can accommodate a maximum of only two electrons.
Yeah.
Do you understand that?
So, oh, the first shell always has more
Two.
than two.
No, the first shell can only accommodate two electrons.
So it doesn't matter about the first shell.
Yes.
All right.
Do you understand it now?
So first shell doesn't matter.
The first shell always can accommodate only two electrons. So,
Okay, yeah.
so if you run into an atom that has only one shell, for instance, hydrogen, you can see hydrogen over here, right?
Yeah.
Good. Hydrogen can only accommodate two electrons. So
Yeah.
the valency is one because over here there is only one electron. It can only gain and lose one electron, right?
Yeah.
That's why the valency is one.
Okay.
Good. So now we're talking about sodium. Watch this. It has one electron over here, right?
Yeah.
Good. How many electrons does it need to gain in order to reach 8?
Seven.
Good. So when it gains 7 electrons, it will reach 8. So how many electrons does it need to lose in order to reach 8?
One.
Good. If this one electron goes away, we are left with 8 electrons over here in the outermost shell.
Yeah.
So it needs to lose 1 in order to reach 8. So between 7 and 1, which one is less?
One is the smallest.
Good. So therefore, what is the valency of sodium?
One.
1, because it needs to lose 1 electron for it to reach 8 outermost electrons. Did you understand that, Romario?
Yeah.
Good. So how about chlorine now? Cl. Can you tell me what the valency will be now?
Okay. One, two, three. So it needs to lose one, two, three, four, five, six, seven. It needs to lose seven to gain eight.
Good.
And yeah, gain and it needs to gain eight. One,
It needs to gain 1 in order to do what?
have eight.
Good. So what's the valency now?
Um, one.
Good. Because the lesser number is 1. If it
Yeah.
gains 1 electron, it has
And
reached
now
8.
all we do is the cross method, which
Thank you.
is sodium Na1Cl1.
And then finally we have NaCl. Did you see
Yeah,
that?
yeah.
Is it difficult?
No, understand it.
All right, let me give you one example to try. Can you do that for me?
Actually, David,
Yeah.
I want to have an example question on my little folder. Can you write it down so I can write what you've written?
Um, okay. Um, Look at this example on the screen. Can you write that down?
Okay, let me write this down.
Okay, so you want to have one little example on your folder that we solved, right?
I want two examples, but you know the one that you set on Google Classroom? It says AL203. I don't get what
Okay,
that means.
okay. This one, right?
Yeah,
All right, let's solve it. Now look at
yeah.
this,
Let me just
Romario.
write this question down.
Okay. Don't worry, this class is being recorded. I'm going to upload it to my YouTube channel and then you can go watch it whenever you want, okay?
Okay.
All right, so when you're ready for us to do this question, let me know.
Okay. Go.
Are you ready now?
Yeah.
All right, so what's the first step?
The first step is write the letters.
The symbols.
Yeah, the symbols.
So we have Al, which is for aluminum, right?
Yeah.
And then which other one do we have?
Um, Oxygen.
O, right? So now the next thing to do is to calculate the valency. How do we do that?
Um,
So we have aluminum over here. Can you tell me what the valency will be?
um, One, two. So it needs to lose three
Mm-hmm. Mm-hmm.
and gain one.
It needs to lose three in order for it to reach eight, right?
Yeah.
How many does it need to gain in order to reach eight?
Five.
Good. It needs to gain five. Between these two, which is the big lesser number?
Three.
So what's the valency of aluminium?
Three.
Thank you. So you can see Romario is not difficult.
Yeah.
How about oxygen? What would the valency be?
Um, it needs to one, two, three, four, five, six. It needs to gain two
Mm-hmm.
and lose two.
It needs to gain two in order for it to reach eight, right?
Yeah.
Good. So now look at this. If he gains two, he has reached eight. How many does he need to lose?
Two.
Good. So what is the valency?
Two.
Good. So you see, the fun thing about valency is once you know the valency for an element, any day, anytime, the valency remains the same. You don't need to start thinking about what the valency will be. So once you know that the valency for oxygen is two, under any circumstance, the valency remains two, okay?
Yeah.
Are you there?
Yeah.
So what's the next thing to do?
The next thing is to simplify. Oh, cross method.
So we have
Al20O3.
we have Al2O3. Did you see
And then you
this?
just simplify it.
Can you simplify it any further from this point?
One, two.
You can't simplify it from any further from this point now. Two
Oh,
and
that's
three.
it.
That's the formula.
Can you write this in sentences steps so I can write this down? Because I don't want to forget, if that's okay.
Okay. All right then. I'm going to write it in sentences in a Microsoft Word format for you.
Okay.
Hold on. Let's let's write it down. So I want you to
Yeah,
write
can
it.
I
I want
quickly
you to,
copy it before we end the lesson?
yeah. So I want you to write this down for me. Step one. Can you see what I'm writing?
Okay, let me write this.
Step one, write the symbols. So these are the symbols. Al and then O. So step two, write their valencies. What I'm writing, hope it's clear enough for you to see.
Yeah.
Good. So the valency for aluminum is 3. The valency for oxygen is 2. Step 3.
Wait, but like, how do you work out the valency? So can you explain like if this loses two
Okay.
because
Okay. Okay.
yeah.
Okay. Good. The valency of aluminum is 3 because for it to have 8 outer electrons, it can either gain 5 or lose 3. The smaller number is 3. For oxygen, can you see what I'm writing?
Yeah.
Okay, I hope you're copying it down.
I am, yeah.
For oxygen, the only way for it to have 8 outer electrons is by gaining 2, which means its valency is 2. Can you write that down?
Yeah.
When you're done writing, let me know.
Yeah, I've done that.
Are you done writing?
Yeah.
Wow, that was very fast. So let me write step 3 now. So can I write step 3 out for you?
Yeah, sure.
All right, so step 3 says cross the elements and their valencies. So how do we do that? We just simply draw a cross like this. Aluminium goes with 2 and oxygen goes with 3. So we finally have Al2O3. Have you seen
Okay.
that?
Yes.
Are you done writing?
Yeah.
Good. So here are the assignments that I want you to. I want you to go back and do those
Wait, can I
assignments.
just draw the circle diagrams,
Oh,
please?
sure, sure. Go ahead, draw them. But Romario, you won't always have the circle diagrams with you in the examination hall.
Okay.
I just
So what
want,
would
I
I
just
do in
want,
that case?
you need to know their valencies by heart.
Okay.
Good. Have you ever written an examination before?
Written one.
Yes.
I've done some exams, but not like only like end of topic ones.
Okay. In chemistry, have you done any examination before?
Yeah.
Do you have a picture of the question papers?
No, it's ages ago.
Oh, do you remember what the nature of the questions were like?
Um, they were just exam style questions.
Okay. Were they multiple options or
There were a few of them.
okay, all right. Go ahead, write what's on the screen.
Yeah, I've done it. Yeah.
All right, beautiful. So can you attempt the questions in the assignment section right now?
Yeah, I'll do that.
All
Yeah,
right,
for
so I
homework.
want you I want you to go and attempt them, okay?
Yeah.
Good. So on Tuesday, when we're having our free class by 6:30, we're going to be talking about balancing chemical equations.
Okay.
This is what we're going to be talking about. We're going to be starting with this. All right?
Fabulous. Yeah.
All right, so at this point, I want to say thank you for engaging with me on this space, Romario. You simply did amazingly well in today's class. I'm so excited that
Thank
we're
you.
able to trash the issue of valencies once and for all. Now you know what
Yeah, thank
valency
you.
means. Is that correct?
Yeah.
Good. And go ahead and do those assignments, and I'll see you in the next class, okay?
Okay.
All
Thank
right.
you.
Bye.
Bye.